have lab after this, we'll go through the female anatomy. And then on Wednesday lab, we'll go through the male anatomy. It's going to take me probably 2 full lectures, or at least 1.5 definitely, to go through the oogenesis, the combination of the ovarian and uterine cycles. What I have done in the notes is I've combined several different books' description of these hormones and tried to find a common ground between all of them. Because if you read 4 different books, you're going to get 4 different ways of describing this stuff. For guys, I can be done in about 6 minutes. Right? It'll be a lot simpler, a lot more straightforward with this. So the first thing I want you to think about is, as we look at our as we look at our ovary in relation to the fallopian tubes, in a sense, that ovaries can be considered a little bit of an endocrine organ, especially the follicles inside of it. But they're not connected directly to these fallopian tubes. Now, I want to find what you guys learned in high school. I may not want to know what you guys weren't taught in high school. At what age do guys start making sperm? All right, so in other words, sexual maturity at some point. 10, 11, 12, 13, whatever it is, they'll start making sperm. All right, when do women start making their equivalent of sperm, their gametes? Very good, you're born with it, in utero. Okay. Now, at what age? So, well, when you're a developing fetus, you're going to have roughly about 7 million potential ova. That's a big family. Tie this idea with the idea of natural selection from evolution. You have 7 million potential ova. By the time you're born, you're down to 2 million already. You've already selected the best of those 7 million. By the time you reach sexual maturity, we've whittled that down to 400,000. So it's the best of the best so far. This is a selection process, basically. When we look at the hormones that regulate the ovarian cycle, the development of ova, we're basically looking at a selection process to see which ones respond significantly enough or appropriately enough to be ovulated with this. Now, all books kind of talk about this on a monthly basis. Well, when we look at all of this here, we're going to be looking at the progression from what's called a primordial to a primary, from a primary to a secondary to a mature. That some books call the Gathian. And we're going to skip the atrial follicle. It's just like, dude, why? Your book talks about atrials. And we'll be looking from the development, getting bigger and bigger into an ovulation process, and then structures called the corpus luteum and corpus albicans as a result of that ovulation process. But right now, think about this, that all the ladies in this room have roughly 400,000 primordial follicles, which means 200,000 in each ovary. And what that means is we're going to have an ova, which is the egg, with your DNA inside of it. And then a layer of simple squamous tissue wrapping around that ova. And we can see that, if you look carefully enough right there, I can see the simple squamous cells wrapping all the way around them. And that's what makes up a primordial follicle. So we'll just give ourselves some simple squamous cells here. And this will be a primordial follicle. Now, in the egg is the nucleus. Nucleus has DNA, and you guys have to keep in mind the ideas of meiosis. Now, you don't have to go back and study all of the various stages of meiosis. But can anybody remember the basic stages of mitosis?
Yes. Prophase,
Telophase.
Telophase.
So what's the very first phase after that actually starts mitosis?
The prophase.
Yeah, prophase, right? Then from prophase we go to metaphase, metaphase to anaphase, anaphase to telophase, and cytokinesis. Meiosis has 2 rounds of this, and there's one really significant thing about prophase 1 of meiosis that happens at another time, something you might have been learning as called crossover. The literal exchange of genetic information from neighboring sister chromatids. Well, this DNA, all of you ladies, all of your ova are paused in prophase 1. I mean, we actually hit pause and they have stopped. If you're 22 years old, if you're 30 years old, if you're 40 years old, if you're 45 years old, they've been paused in prophase 1 for that length of time. Which is one of the reasons why we start getting genetic issues as we get older. Our mitotic spindle formation starts to get a little wonky. Non-disjunction issues, if you remember that conversation, begins to take place and makes it more likely for a genetic defect. Because the machinery has been in existence for X number of years. Which is a benefit guys have. I mean, we don't start making sperm until we're sexually mature, and then we keep doing meiosis non-stop. We never have any pausing, which will, bless you, reiterate that idea a bit later. So all of your DNA, let's just put, I'll just leave it as meiosis. Paused, whoops, in prophase 1. And we're going to have to get you to the point that makes this nucleus reawaken and move forward. Now here's the hard part of this. Most books talk about the average menstrual cycle as being how long?
20 days? 30 days?
It's about 28 days on average. All right? And we're going to divide this up, and we have slides for this, into 2 different things. One's called the follicular phase, or some in terms of the reference of the uterus is the proliferative phase, and then we have the luteal phase. For right now, the first half of the menstrual cycle is variable. The first half of the ovarian cycle is variable. And probably every single woman in here has experienced this, or you have friends that have, where 1 month your cycle is 28 days, another month maybe it's 32, 33, 35 days. And other days it might be 26. And that variation comes on only the first half of this cycle. The latter half is not variable. And we'll explain that as we get to it. Here's the second part of this. Most books talk about this on a month-to-month basis. But this is actually about a 2-year process. So let's say I am a 10-year-old female. I have not yet actually had my first menstruation. My hormones have already begun to go through the process of this. So by the time I hit my first menstruation, about, let's say, 2 years later, for my very first ovulatory event, I'll be looking at a mature follicle doing ovulation. It took 2 years to make that thing. So every month, I want you to think of 2 things happening simultaneously. On each of my first days of menstruation, I'm thinking I'm beginning a new ovarian cycle, which means one of my mature follicles is going to ovulate, and I'm going to be activating a whole new group of primordials to begin their 2-year journey. Every month, we start a whole new group of primordials. So on January of year 0, right, it'll take 2 years for those primordials to ovulate. So they'll ovulate on year 2. But on February of year 0, open up a new group of primordials who in 2 years on February of year 2 will then ovulate. And then on March, I awaken a whole new group of primordials who on year 2 of March will ovulate. So every month now I'm going to have somebody ovulating, at least 2 years from now. Because they were started 2 years ago. And it's a long process. Now, we're pretty much done for this, all right? Just sit back and look at this because for those of you that are going to try and get ahead of me here. After reading all these books for several years, trying to figure what is the best way to communicate and visualize what they try and say in words, I create my own little version of a regulatory pathway via PowerPoint. What you have up here is your hypothalamus, and these are my follicle cells over here, right? There's a granulose cell, granulosa, and a thecal cell granulosa cell. We're going to be looking through, and we're going to be looking at how the levels of hormone, of estradiol, see here it's low, during the paracrine signaling. Don't worry about writing this down, we'll do this on Wednesday. But now I have medium levels actually going hypothalamus and doing negative feedback. A couple of days later, I have high levels doing a stimulation pathway plus 2 new hormones. We're looking at how the levels of hormones will change, and what they do changes. The estradiol could be either a stimulation signal or an inhibitory signal, depending upon the amount of hormone production. And we're looking at this little by little by little. This is my attempt at trying to summarize several books at once into one average thought of how this works with this. I'm going to walk you through it step by step on Wednesday. We're going to look at one slide, talk about each little line, what it means, what significance, why we're doing inhibition here, why we're doing stimulation there. I'm not terribly impressed with McKinley's description of this. So read it through once in one as a glossary, look at his diagrams and go, okay, I can see how John is putting that in his notes. He's leaving lots out that I think are significant enough to make this more interesting and a little more of common sense after you guys get the feel for it. So we will see you guys on Wednesday.